This video is about comparing nuclear equations and nuclei to fruit bowls. A nuclear equation is a shorthand representation of a transmutation, like a code to show what is happening in the change. And a transmutation is when one atom turns into another one, really, like carbon turning into oxygen or nitrogen. Now, nuclei are like a fruit bowl with two types of fruit. Here's a fruit bowl. You can see it's got two types of fruit in it, all right? And if you look at a nucleus, the way we've drawn it, the way it's typically drawn, you're going to draw circles that of two different types, one being protons, one being neutrons. This would end up being a helium nucleus because I've got two of each, or rather two protons, not two of each. And in its notation, it would be this. It would be 4 over 2 He. In the fruit bowl, I'm going to arbitrarily say that the number on the bottom is 5 because I'm going to say that it's the number of apples. It doesn't really matter. It could have been oranges, but I just went with the apples. And the top number is going to be the total number of fruit, and that's going to be 9. Now, to explain that analogy, to be clear, the thing that we're comparing are the fruit bowl and the nucleus, and I'm going to compare them between the parts. And for a fruit bowl, you've got oranges and apples, and for a nuclei, you've got protons and neutrons. The second thing are the numbers. The top number here is the total number. The bottom number is the top number on the fruit bowl is the total number of fruit, and for nuclei, it's the mass number. And that's two things added up in both cases. The bottom number for the fruit was the number of apples, and it's the atomic number or the number of protons with a fruit bowl. Now, nuclear equations are like fruit bowls breaking apart or bringing together fruit bowls. Let's say I had this fruit bowl and I started with this, and I break it apart into two different fruit bowls. Here, the first fruit bowl has 3 apples and 2 oranges, and the second one would have what's left over. 2 apples and 2 oranges, making a total of 4 pieces of fruit and 5, and that equals what I got at the beginning. Now, here is a visual of a transmutation, one nuclei turning into another nuclei, or one nucleus breaking up into 2 nuclei. Here's my original nucleus. It breaks up into one nucleus here. It's a new one, and then simultaneously makes a second one. Now, here are the reactants and products. All right? And here's what they start at, and here's what they finish at. As an equation, I'd write that as this. I have 6 protons and 8 neutrons. That makes a mass number of 14. That's a carbon atom, an isotope of carbon. And the first one is an isotope of hydrogen. It's got 1 proton and 2 neutrons. It's a tritium. And then what's remaining is an isotope of boron. It's got 5 protons and 6 neutrons.